Last session before lunch. I hope you'll survive. I had a lot of fun yesterday evening, maybe a bit too much fun, but it was great. DDD, CQRS Event Sourcing, yeah. So I'm going to try to talk a little bit about how these things are solutions or tools to problems, and maybe you don't even have that problem, so I'm trying to come up with like an example, like a pragmatic approach. To try to show you like how these things work together to solve problems, but also that you don't necessarily need to use them. I've talked a lot about these topics over the last years. This is more like a starting point. I also like it to be interactive since it's the last session before lunch and everybody's tired. Yeah, this is me. I'm always trying to learn new things. I like to be challenged. I love that. Not at work, but at least here at the conference. That's my Twitter handler, and I'm always trying to find new stuff about tools, architecture, people, because that's a big part of our job. So let's start with, some stuff I work on, not really that. A modeling exercise. This is always very difficult, to come with some example that really makes sense. I don't know if I will be succeeding in that, but at least I will try. So I recently got a mortgage, and I was trying to figure out what do you need for a mortgage, and what kind of concepts are part of that. So given this domain of a mortgage application, I think is that the correct term? I should probably trust us. Yeah, you apply for a mortgage, and there's a whole bunch of documents you need to provide. It's the pay slip, it's your proof who's the original owner of the house. Maybe you need to show some pay slips from the last year, or like yearly stuff, some certifications, maybe life insurance, all this stuff that tells the bank that it's all okay, that you're going to get that mortgage. Especially, I don't know if it's in Germany, but in the Netherlands, prices are huge. Houses are actually way too expensive these days. And there's usually somebody involved called a loan officer. Not necessarily a girl, could also be a guy, and they're supposed to help you. Of course, they get paid for that, to try to understand if this mortgage is actually going to work for you. They also advise you, the different models that you have, etc. So, how would you model this? Like, yeah, I mean, you can talk about concept. This is what I used to do. I looked at this stuff and I say, hey, I have a mortgage application. Let's create something in UML. Anybody still can read UML? It's ancient art. It's a lost art, I would say, yeah. This is what we used to call a class diagram. But I have a mortgage application, and then I came up with something like a legal document because, yeah, I'm a developer. I need to come up with something that makes sense. And the mortgage application has a collection of these legal documents, and every legal document has a signature, and the signature has, I don't know, a timestamp. When was it signed, that particular document? Maybe a sequence, I don't know, if it's really important, and then a reference to a loan officer. Make sense? This is what we used to do, like 10 years, 20 years ago. This is how I learned it at university. Well, I didn't do university, but something in between. This explains, by the way, everything. So yeah, I felt like this could actually work. Who would model it like that? Yeah, but that's how you start. Because how would you do it differently without actually understanding the domain thoroughly? And that's kind of the point. Because did I mention any business rules? No, I didn't mention any business rules. So this is the only thing you can. You only know these things. You have a couple of concepts and you can come up with properties. If you're a database developer, this is probably the only thing you look at, like attributes, columns, and tables and stuff. But I don't know anything here. So let's add a business rule. All these documents, they need to be signed off before the application can be approved. That's a business rule, makes sense. So the point being is already, like, you can't really model something if you don't understand the business, the rules, and what they sometimes call the invariants that apply here. So I have a business rule. Would I use a database? Like maybe a foreign key constraint. So I have something in between, and I'm really trying to think as a database developer with tables and foreign key constraints and unique constraints. That's the way we used to do that. So yeah, I have a relationship here between what is called proof and a flag, and I use just a foreign key constraint. So you can actually never remove a signature after it has been added to that. It's just the database will prevent me from that. Is that a good model? Do things make sense? No. No, because we don't do database anymore. I used to work in an Oracle environment where all the developers put all the business rules in PL/SQL. Huh? Cool? Yeah, you have seen that? Anybody seen the PL/SQL business rules? Try to create unit tests for that. You can't. Yeah, you can, but they will be brittle and unreliable. They will fail, and you have to apply. No, I don't even want to go there. It hurts really much. That's one way of doing it. And then you put something like a transaction around it, a transaction boundary, so to prevent people from concurrently updating this construct. And this is a way that a lot of people try to do. So yeah, I can think it can work. Would you solve it functionally? That's also a way. I mean, with developers, we're trying to solve the problem technically. We want the system to be transactionally consistent. We want to prevent the system from failing. But maybe if you talk to a product owner, yeah, you can do that. You can actually talk with people as a developer, come up with a functional scenario that allows you to solve the problem without building any code for it. In fact, if you look at the legal document in the middle, there's a sign method, but there's nothing to remove it. Actually, even the relationship is broken for some reason. See, that's what you get if you do UML. But you're basically saying like you cannot remove the signature. When the signature is set, you cannot remove it. So it will still be valid. Does it work like that in real life? No, probably not. But yeah, it's an approach you can take. And in real life, the situations are much more complicated, but you can solve a lot of problems when you talk to a product owner. Otherwise you may be solving a problem that doesn't really exist, Or are you going to try to identify the invariance? And this is where we enter the world of domain-driven design. Is the mistake I made in the past, I've made the mistake many times, is to try to just take the concept, create classes, object-oriented programming, add the attributes, and I'm done. No, but you need to understand the invariance. So I took a different approach. I kind of said like, the mortgage application is, of course, really the important entity here. And the relationship between the legal document and the person that signs it, I encapsulate that in a separate thing, in a separate class. It's called an entity there. It's called proof. And now there's terms in there, like, by the way, use the ubiquitous language, obviously, because, yeah, that's the language of the business. I talked with the loan officer. I talked with the people that are talking with the loan officer that try to, get these applications into the system. But, yeah, then you end up with these terms. This proof object protects the signatures. Why? Because it's part of an aggregate. So in DDD, I mean, aggregate is an overloaded term. You've seen the thing on the wall with all the different answers. Domain-driven design defines aggregate in a really specific way. And it's a transactional boundary. It's a couple of entities that are protected by the entity that's the entry point, which is in this case the aggregate root. That's what they call it. I mean, we can have a full debate about what aggregate means, but in this case, this is what the terminology does. It protects the entity. You cannot actually update and use optimistic concurrency. That's why there's a version on the mortgage application, a version property. It protects the signatures. And it just has a reference to a legal document and a reference to a loan officer. And this is difficult because you're actually changing your domain, the way you model your entities based on the invariance the system has to protect. And if you ever read the book by von Vernon, and there's a couple of PDFs that predate that book, he also talks about if the system needs to protect the invariant, like it should never go wrong, you should never be able to add more signatures, or you should never be able to have an order which value is more than 10,000 euros. It should never ever happen. Then the system needs to protect it using aggregates that protect that. But he also says, like, if the system can allow temporarily to violate that invariant, and it may eventually fix it up, then you don't need to encapsulate it in invariance. Because the problem with these aggregates is they're also like a concurrency. How you say that? They can cross to contention. If your aggregate is too big, because you want to protect all your invariants, all your business rules, and the same object, the aggregate is updated or touched by lots of different users concurrently, you suddenly have all these people running into an optimistic concurrency problem. And there's ways to fix that. We'll talk about that in a second, or a couple of minutes. So von Vernon also tells you to make them small, because the smaller the aggregate, the less chances that multiple users, multiple systems are going to be affecting the same aggregate. Make sense? This is difficult, by the way. This whole thing is also called the bounded context. So in this case, we have a couple of things that live in the same world. Usually these are the things that the loan officer deals with. There might be also a system on the side of the mortgage provider that has different concepts, that also has documents and representations, but these may be different entities with different properties and they protect different invariants. They live in a different domain. So even though we have, if you look at the much bigger scale, you may have proof and a legal document and a loan officer, they may have a different representation in their system. Or even maybe it lives all in the same system, but it's still a different subsystem. That's what bounded context is, kind of identifying the differences in the domain between different parties and trying to make sure the language within that boundary is consistent. I kept it really simple here, not to confuse everybody too much. But yeah, this is your model invariant. So the next time you're trying to change or trying to convert a requirement about concepts into a domain, into an implementation, a model, try to think of the invariants because they change the way you look at this stuff. Now, this is the modeling part. How do we build this? How do we architect this? So, more requirements, because everything should be driven by requirements. Given reading should be fast and collaboration is low. In other words, there's lots of readers, but there's only a couple of people that work on the same thing at the same time, because typically a loan officer works alone for a particular client, right? Would you use a CRUD architecture? Who would use a CRUD architecture? Yeah, it could be. I mean, it solves the problem, you know, and I use a relational database, and maybe I have a couple of materialized views to make it fast. It can work. There's no reason why this is a problem. As I said, yeah, we want the reads to be fast, and there's not a lot of people working on the same thing, so the chances that you're trying to update the same entity concurrently is pretty low. So yeah, and a materialized view allows you to build really fast queries, especially if you have a good database. So it's perfectly fine to do that. Or maybe a NoSQL solution with some fast searching. Who would use this? There's no wrong answer, that's the point here. I'm not saying anything like this is the truth or this is the best way. There's no wrong, this works as well. It's a bit more difficult to deploy, although, you know, with containers everything changes so much, it's much easier to make the complicated deployments. But in this case, yeah, I mean, why would I use a relational database? Because then I have to solve this object relational mismatch. And if you ever worked with Hibernate and tools like that, Entity Framework, it really tries to abstract that mismatch, but it still becomes an issue, especially if your reads and writes are starting to interfere, have a conflict of interest. So that could be done. Or maybe acknowledge the fact that reads and writes are different things. What is this? What? CQRS, yes. Again, CQRS, not again, I didn't even explain it, but in this model, you actually acknowledge in the fact that writes are governed, or the code and the complexity that defines the structure of your domain is mostly defined by business rules, as we talked about. But reading is a completely different thing. And maybe you want to acknowledge this difference and optimize your read side for reading and optimize your write side for writing. So applying business rules. And then it may look like something like this. Your app's sending commands. Commands are like things from ubiquitous language. Apply for a mortgage, register some proof, you know, stuff like that from the ubiquitous language. And then you have maybe, I don't know, an HTTP API because we're all building single-page applications with JavaScript these days. A domain, data access that writes this information in a document. And then we have a query side, which in this case uses a combination of an index, like the most NoSQL solutions like Raven or Mongo, they have indexes, and maybe Elasticsearch for really complicated searches. Who would use like something like that? CQRS is kind of, for me, the default that I'm using, but it's mostly because, yeah, it's dangerous to say that because, yeah, you may actually over-engineer your system. That's a chance on that. But like my current system, I started with that because, yeah, I like this separation. It allows me to think about one problem without having to understand the other problem. Because as soon as the system becomes bigger, chances are that these two worlds are going to be conflicting. So acknowledging the fact that they're separate makes sense. But you don't have to. It's a choice. That's really important. These are all choices, and they come with pros and cons. Well, the right side captures the business processes, obviously. Commands use ubiquitous language. Yeah, are typically eventually consistent. That's one of the problems, by the way, with NoSQL solutions. The indexes are always running a little bit behind of documents. That's where the speed is coming from. But let's add another requirement. Changes have to be audited. We're talking about a mortgage system. We're talking about something like people put their lives in it. I mean, if I don't know, my wife always makes fun of, like, she only stays with me because we have a mortgage, because there's so much money involved. I hope it's not really true, but... So you probably want to track really meticulously what is happening, who applied, what proof was added, what proof was removed, when was the signature set, who set the signature. So given this requirement, what kind of system will we build? What kind of architecture will we use? Any event sourcing? No. Sorry. I'm just building something like an extra table here, or like a document, an audit trail. I mean, any database supports something like that. Relational databases have change tracking. Most NoSQL solutions have something like a changes feed that you can subscribe to. That's enough. If that's the only requirement, why would I go further than that? I mean, that's the whole point of being an architect, is trying to balance all these requirements, and the functional and the non-functional one, but also the people that you work with, the culture of the company, the skill level. You know, can you maintain all this? You try to balance all these different factors and come up with an architecture that works. And that answers. And it doesn't mean you can't change in the future. But yeah, this is all I need. This was the requirement. Make sense? Mm-hmm. All right. Another one. Many folks works on the same document concurrently. So now we have the extra situation. Of course, it had to be fast. But, you know, on the hindsight, we discovered that it's actually pretty common for a lot of people to be involved in this mortgage application. I initially didn't know that. I thought it's just a loan officer. Or works alone, types of stuff in his in the terminal in the office of the I don't know, loan broker or something. I don't know what you call that. But eventually what happened is that over time we discovered that there's a lot more people in the other offices all involved. They do checks, they verify, they scan proofs, they cross-reference them with external systems, add additional signatures. So it becomes a much more elaborate process. So the requirements change. I've already built this system, now what? Now I need to support that. So now maybe it's time, event sourcing. But should we? Yeah, it's cool, of course. Event sourcing is cool. You can hire people because you, as a company, use it. But it comes with a cost. And I'm not going to talk too much about the costs, but it's just like the fact. But what it will look like? Well, the same model. I mean, CQRS and event sourcing are two completely orthogonal concepts, but they really go well hand in hand. That is just a fact. I mean, but the difference is, this is what we had, but instead of storing the domain into, I don't know, a NoSQL database or relational database, we actually store a history of what happened functionally in that domain, typically called events. And quite often what you see, it's more like a convention. The events have the same name as the commands, so they're written in the business language, but in the past tense. So a mortgage application was approved. A mortgage application was, oh, I applied for a mortgage, actually. All of this is stored in there. That's pretty cool because it's a great unit for unit testing. I don't know if anybody's practicing TDD, but for me, a unit is not necessarily a class. It's one of the mistakes I made in the past. But this is really cool because you can actually spin up the system and you can even create, because this event store is a really stupid thing, it's just something in memory. You could create tests that execute an HTTP API, you know, send a command, apply for a mortgage, and then verify on the other side that the events were emitted from the domain, the right ones, and nothing else. It's one of the events that Greg Young always used. You can do that. It's quite nice. I've seen this being used in production systems quite well. Yeah, they're a bit bigger, but you probably built up some plumbing, you know, some infrastructure to make those tests readable, but it's perfectly valid to do that. Cool thing is you can also replay those events into a new domain. Let's say the domain really changes drastically. You can take those old events, and those events are functional. They really try to capture what happened in the past. You can replay that to build up a new structure or convert them. However, to be able to do that, you do have to understand the domain thoroughly. You really have to work with a product owner, and product owners will love that, to understand what happens in the system. It's not just a developer thing anymore. But that's really cool, because you're going to talk about, I mean, that's why event storming also works really well with that. Because event storming tries to capture all these things that happen in the real domain, the real business, trying to change that into events on a post-it. Event sourcing works quite well with that. I'm not saying it's like a one-to-one mapping, but quite often it can be a one-to-one mapping. However, don't make the mistakes as I did, like these events should capture business intent. They should not be like properties, just like title change or something. That's way too small, way too fine-grained. Cool thing is you can also look at the state in the past. You can actually look at the history and replay your entire system until a point in time and then see what the state was at that time. What happened with this mortgage application? What was the state on the 1st of January 2019? That's something you can do. You don't have to. It kind of comes for free. Nothing comes for free, but it's something that's part of that. And auditability definitely comes for free because that's the whole point. Your event store will contain an entire history of everything that happens to the system. Make sense? One of the disadvantages, and this comes from a former colleague of mine, he says like, yeah, but if you look at the system like that, it's quite often more difficult to understand the entities and their relationships. Because with event sourcing, I mean, if you used to build a CRUD system, you might have seen those classes with properties, and if you go through the property to a related child, the ORM will dynamically load with n+1 queries, which were usually really slow. All the related objects, you could really traverse to the domain. With event sourcing, you can't do that anymore. Every aggregate, the thing that protects all these little entities, is stored as one stream of events, and there's no relationships other than maybe a functional relationship. And it makes it a bit difficult if you look in the code, and the code is supposed to be documentation, to understand what happens in that system. But we have a read side as well. Because this event thing, yeah, it's just a list of events, and maybe it's just stored as JSON objects. You can't really query on that. Give me all the signatures of this loan officer related to, like for a particular time period. What did this person sign for? Because we found something, you know, something suspicious that we want to look at. So you need the right side. Sorry, the right side, well, it's the left actually. The left side, which is the read side as well. And what you generally see is that there's something called a projector, and there's different terminologies for that, terms for that. But a projector is the thing that takes a couple of events and creates a projection, so something that you can also call the view, that contains the information in a format that makes sense for that particular query need. That's a way to do it. And what you use for that, that could be a relational database, but it can also be something else. And again, this is really great for unit testing, because you have another boundary, and I love boundaries, because I can build this whole thing. I could even use an in-memory RavenDB database if you're in the .NET space, pass in a couple of events, because the contract between the read side and the write side are the events. This is what you actually expose. So you can pass in a couple of events in your unit tests, and then do the HTTP query and verify that the result is correct. In .NET, you can do that with OWIN and ASP.NET Core. I don't know if there's any equivalent in Java. I've still not heard any, but you can actually do that without touching the network stack, which is cool because you have a nice boundary. It's much bigger than a simple class. And all the details about how this is stored in the database, that's just an implementation detail. And that's also why these projectors should be as autonomous as possible. So if one page needs information and another page needs other information, create two different projections for that. That's probably best. So you can also rebuild them when you need that. If the data changes, of the format that you need for a page changes between releases, you can rebuild it. That's also quite nice. Of course, there's lots of pains that you can run into, but I'll not be talking about that. Yeah, you can of course scale this whole thing, especially if the read side becomes asynchronously. It eventually catches up with the domain. You can scale this out really well because you don't need relationships in your database anymore. You just create multiple projections. They can even use their own storage mechanisms if you really want to do that. But does this apply to the entire system? Should we apply event sourcing as an architecture style on a very high level? Is it like if I'm building a new system, I should make a choice? CRUD versus event sourcing versus CQRS, or not versus, or CQRS. Is this something that I should make at that level? No, it's not a top-level architecture. Greg Young has been telling everybody since day one. It's an implementation. It's more like an architecture style. You can also say, do we need different architectures per boundary? Yeah, I have an example, a drafting domain, where we draft up policy documents. We may have a domain that's more about executing a policy, which has different characteristics. And maybe there's a search domain that is just about displaying information or really being able to make like keyword search on large sets of data. Every part might need a different architecture. For instance, the drafting domain could work with a simple CRUD kind of architecture because you don't need any of this complexity. There's not a lot of people working in parallel. So all these things I showed you earlier, all these specific requirements, you should evaluate those requirements against the different parts of your system. Maybe the policy execution domain does need all this complexity that we showed you. And there we use event sourcing and CQRS, whereas the search domain here is just, I don't know, Elasticsearch or a simple Lucene index. Yeah, some indexing-based architecture. That's perfectly fine. And if is anybody doing microservices or being pushed in that direction as the ultimate solution to all your problems in the future? Yeah. Every service could have a different domain. Sometimes the domain does not match to a single service, that's possible. But they all need to have different characteristics. And based on those characteristics, the non-functional and the functional requirement, you choose an architecture style. And of course, these are the 3 examples. Don't take them for granted. There can be others one as well. And the slides will be on the internet. And maybe, yeah, you want to communicate between that, because that's one of the mistakes, something that I see is that the events inside this policy execution domain, the events from event sourcing, since they're written or described in the ubiquitous language, in the language of the business, it sounds like, hey, that's a really cool way of integrating all my different domains. And that makes sense. I've seen a lot of people do that. Even worse, they introduce Kafka or something like that, and then everything works with events. But the problem is, it's an implementation detail. You know, this whole thing of encapsulation, one of those object-oriented principles, also applies here. You don't expose the internal details of your system outside your bounded context. Yeah, maybe you use webhooks to expose more coarse-grained events or something like that. It's actually there, yeah. That's a really nice way of doing it. Depends a bit on the platform you're working on, but that's happening a lot. I mean, that's why we have gRPC now as a really fast protocol, because all these servers need to exchange data, but we're not exposing events. And using a bus for that is perfectly fine, but publish something coarse-grained, something you control. Not the events. It might be, by the way, it's a nice solution to project those fine-grained events inside your domain into more coarse-grained events. That's possible with projection techniques, but you do it on purpose and you control the schema. A querying exercise, because we have this domain. List of proving documents with state, mortgage number, and last loan offer that signed it. So we have this domain, and we modeled it using event sourcing, we built it using event sourcing, so now we can't really query it. So how would you query that? Anybody wants to participate? Almost lunched it. Well, you can do it in different ways. You could have 2 projectors, one that projects a list of the mortgages, the proving documents for the mortgage, and one that has a list of projectors, loan officers, sorry. So you have 2 of them, and they both write to some kind of query store. You see on the bottom, the loan officer, actually there's load officers, okay, and proving documents. And they subscribe to the event store, it's listening to all the things that happened in the domain, and we have 2 nice lists, and you can then join those tables. That's a way of doing it. And it works quite well, okay. Unless at some point you discover that the list of proving documents becomes so big compared to the number of loan officers, there's only a couple of them, you want to somehow independently scale the way you persist this data in your system. Maybe you want to build them up in an independent manner. Like those 2 projections become asynchronous. They decide themselves on versions of the code base to when you redeploy the system using Blue redeployment, that there's a new version being deployed, that it needs to rebuild that table. And then suddenly if you start joining information, you're actually joining information that kind of represents different points in time. So that's kind of a risky thing. I've done it myself because it sounded like a great idea, especially because if one of those tables is really big and the complexity in the projector is high, people tend to try to reuse it because, yeah, we don't want to maintain another projector that's virtually the same. Again, as everything in our job, it's a trade-off. Alternatively, you could say, I'm building a dedicated projector, and that's the most puristic approach. So I'm building something that listens to the events from both the mortgage application and the loan officer, everything that happens there, and the signatures, and builds up something that completely matches this structure, which is the proving document projection. And that already contains everything pre-formatted exactly the way the UI is expecting it. If you make it autonomous, you can even decide to use different storage. Why do you need even a database for that? Maybe you just do it in memory. Or maybe you have pre-generated JSON that you can feed in your HTTP API. You can all do that if you're autonomous here. You have the flexibility to make decisions on that. Every projector could potentially have its own storage mechanism. And that's a completely valid thing. You could even do caching. But everything is there. And you have the flexibility to make it as fast as possible, which comes with CQRS. The fact that you are decoupling those two worlds, you can optimize for what you want to do. It's just like if you write code. It's optimized for readability, not for writability, right? Yeah, there's one issue with this approach. Especially the app, because what you know, if everything is asynchronous, it's possible that the data that you query for is stale. So if you build a system, a UI, where you've just approved a document, sorry, you approved a mortgage application, if right at the same time your UI will refresh the list, it's possible that this approval state is not visible yet, because it's asynchronous. That kind of comes with the territory. You don't have to. Again, you can make some of these projections synchronous if it makes sense, but making everything synchronous means essentially I click on a button to approve the document, and then all my projectors that are synchronous have to run before this click continues. And if your system is really big, that can take a while. You may have like seconds of delay, and people are spoiled these days. I expect my websites to be really fast. So again, there's a trade-off to be made there. If you make it asynchronous, you need to deal with that. And there's different tricks to solve that. You can simulate this behavior, like if the document was approved and the command was sent into the domain and the domain accepted that, there was no exception, then the UI can just assume that it's correct and fix up the results from the query side with the updated state. You kind of simulate that. Other things is like you can solve it functionally. Yeah? The textbook example is of buying a book at Amazon. By the time you buy it, everything seems to be fine. You think you paid. But it's still possible that you're not getting that book immediately because it was out of stock right at the moment. They're not going to do a pessimistic lock on the inventory system. There's different ways of doing it. You can also use e-tags, and it becomes more complicated with load balancers. The guys from the event store team, they have a lot of experience with that, especially Jao here. Yeah, but these are challenges that you need to solve at some point. More examples. Yeah, you have a new version, and it requires a change in the projections. What do? What options do you have? The domain side hasn't changed, but the read side has changed. So you can do a couple of things. Let's say you have a load balancer. You can do something like a fully automatic, out-of-place blue-green deployment. How does it work? Version 1 of the application is available. Version 2 is deployed side by side. It has its own projections. It's a completely independent deployment of the product. They may share those two event stores. You can do that if you want to. But in this case, I'm doing like, no, the new version, if you start it, you actually run it. You deploy and run it, maybe automatically in Terraform, AWS, Azure. It will return 5 with 3s. And since there's a load balancer in between, it will try to redirect the traffic. It will discover that the new environment is not yet ready, redirect everything to the old environment. Then in the meantime, you start to copy over all these events, which is just a full history of everything ever happened, into the other event store and project them into the new structure. And you can do that per projector, by the way. It's not like a full architectural solution. When this is done, when all this work is done, then the new version will tell the old system, now you need to become offline, which will start to return on 5 or 3s. And then generally what happens, like, if this took a couple of hours to copy over the data, at the point the old system was offline, there might be a bit of a delta in between. You copy over the remainder, and then the new system becomes available. You can completely automate that with event sourcing. It's pretty easy to do that. Other options is like an in-place upgrade. You essentially just have a projector, and the projector then completely owns the schema, and that's why NoSQL solutions are so nice. You don't have schema. You have document versions, and it just decommissions version 1 of that particular projection, and version 2 is just projected from there. So essentially, you deploy a new version, the new product version supports the old schema and the new schema, you build up the new schema, and after that is done, you just make the switch over. That's it. Options, choices you have here, trade-offs to make. But it does involve some downtime, especially if it takes a while to rebuild, unless you really make the code backwards compatible, so that old queries go to the old projection. So, as I said, like your domain is completely encapsulating the business rules and the terminology of your client. What if that terminology changes? That's quite common, right? You've chose the wrong term, you use something a bit too technical. So instead of a customer was created, they actually want to call it a customer was registered or something like that. So you have to evolve the event schema. Let's say you have HTTP command API that invokes a command handler. That's kind of a convention that you see in those CQRS-based architectures. It loads a customer from the database, which means it's loading the history of that particular customer from the event store. There's an event, customer created event, and that one didn't really work well. There was a developer that thought, yeah, you can use create. I remember somebody actually saying you should never use words like create and delete and update because these are technical terms. CRUD. They don't capture anything from the business. I didn't create an address. I moved somewhere. I bought a house and I physically, moved there. I might make a mistake in my address, so I want to fix up the address or correct it, but I'm not just updating because updating doesn't say anything. So there's a converter that will run on the fly. That's one of the ways of doing that. And it may, take that event, split it up. It might even merge multiple events because over time you also figure out that your granularity was not completely right. It didn't completely match. It was too technical or it was way too coarse-grained. You make decisions, and that's what it is. Code changes over time. It can run as part of migration, so if this becomes really like a performance burden, you can also do this as part of this upgrade process that I just shared. And it can change the identity. Maybe the functional key of an object changes over time. You started with Active Directory usernames, and then you moved into like an OpenID Connect scenario, and you want to change it into GUID or something else. But then at the end, the converter just produces a new event. A customer was enrolled in our system, which sounds much more business-like. And the rest works just exactly as it used to work, because the rest of the events are unaffected. That's a way of doing it. It's not really that exciting. So we have 10 minutes left. Yeah. What else? Yeah, there's a bug in the projection. Happens. I mean, I produce lots of bugs. Rebuilding is slow. Can also happen. You can then make sure that you build fast autonomous projectors. And I already touched a couple of this. Like you can have projectors that are optimized by using a different storage technique. As I mentioned, can be HTML, can be NoSQL database, can be in memory. I mean, if every projector just subscribes to this event store and receives all the events that happened, it can just build this stuff on the fly. Maybe it's perfectly fine when the application starts. You can use raw SQL. You can use an Hibernate, whatever works. Actually, using an ORM sounds weird, since you've already updated or you've designed your projection to be optimized for what you query for. But there's lots of advantages because you still have to process events, you have to load the record from the database, update it. I've actually seen, I have a blog post about it, that using an ORM, which has a unit of work, maybe you know this concept, can be really fast because you reduce the number of updates to the database. But it's not one solution that fits everything. Choose the right technique for the right type of projection. And maybe if you forget half of this talk, I think the gist of it is use the right tool for the right job. And only for that job, and if another job needs a different tool, use a different tool. Makes sense. But you can do cool stuff. You can do caching strategies. You can say, because you know the intricacies of that projector, you can do partially the work in memory, some in a database. You have lots of options there. And that really gives you the strength of event sourcing instead of all the pain points that people highlight so often. Stream by stream is also a nice one here. You can also say, like, typically a projector is kind of like a projection on the events. But if there's a direct correlation between the object you're projecting, like a mortgage application, and the way it's supposed to look in the projection, you can also say, I'm going to load the entire document from the event store and project that separately, instead of doing it event by event. That's a nice optimization technique. I saw a couple of guys doing the project that I work with now. That's a nice solution. Now, what if you have like 4 years of data and rebuilding is still slow? Well, you can do stuff like you can archive all the events. Event store, you have like a graph projector that tracks all the dependencies between the documents. There's events there, a document was created, a couple of other events, the document was closed, and at that point the graph projector knows that it is closed, tracks all the dependencies, and then if all the documents related in this graph are done, you can mark it as archiving, or you can archive the document. Do that in the event store itself. That concept itself is also an action that the system needs to maintain. Then you have a projector with active projections, and that can want to actually clean up some projection there. It's a pretty elaborate solution, but it works. We used to call this tombstoning. And then an archiving projector that actually marks all those events in the event store as archivable. So you're kind of saying, like, we know this concept. We know that if all documents related to each other, the mortgage application with all the related proofing documents have been finalized, we don't care. You start to optimize by marking a part of the event store as archivable, which means the next time you need to rebuild a new version, you can skip a lot of the data. That's a way to solve that. And you can go further. You can even delete all the events. Not going to show the whole thing, I just showed the final picture. You're basically saying, I'm going to create a snapshot of that document, put it in the Lucene database, and I physically delete that history. Again, depends on what the requirements are. Can you actually delete history from your event store? Because it's from an auditability perspective, this may be wrong, but it's an option to do. What else? I think, capture the original name of a loan officer. That's one example that you can use. There will be lots of examples where you want to change the information you captured in the past. You want to enrich the information. There's lots of different solutions. I have a picture of that. Maybe a lookup, something that runs like you have a projector, and it also subscribes to information about loan officer, creates a little bit of a lookup, so that you can actually look at the loan officer's information from the past. Maybe there's a legal reason, and the loan officer got married and changed his or her last name. You can actually track that. You can also do this on the event side by converting this, but it becomes a bit more complicated and difficult to reason about. But it's really cool because everything is a boundary, and it's also really well testable. It's really cool. Which brings me to the final slide. What if you run into something that I didn't mention, and you will? Then I would say, ping me or email me. It's self-plugging, but there's so many scenarios that you can run into. It's a really cool architecture-style event sourcing. Comes with pros and cons. I blogged about it. I published a lot of presentations about that. We have the folks from Event Store here. They probably have seen everything already, because if you build a library, then people will actually use your library in ways you never conceived. So if you build a library, you work with your clients, you've seen everything. This is the story. We have 5 minutes left for questions, if any has questions. Questions? In that case, I thank you for your time and hope you enjoy the rest of the conference.